Okay, I wanted to run through a solution to this problem 257, the challenge question that's for homework here. Mostly because it's sort of tricky to read it and draw the picture and set up what you're looking for, but I think it's just helpful every now and then to see a problem get solved in a way that might help you to then take on another problem like this. Okay, so the first thing I'm going to do is just read this question and make sure I understand it. I'm going to draw a picture. Okay, so point Z is on side PR of triangle PQR such that these two angles are congruent, and then we know when we subtract these other two angles we get 42, and we want to find this other angle. So I'll just give you my first impression of this question. When I read this, I think, geez, I can't really picture what all of that is saying. So I'm going to go ahead and try to draw the picture. So drawing the picture here is probably the most critical part of this question. I would not expect the picture that I'm going to draw to be to scale in any way, shape, or form because I don't really understand the question yet. But I'm going to go ahead and draw a triangle because I did hear that a triangle has to do with this problem. So I'm going to draw a triangle and I'm going to represent what's going on best I can. So we've got a triangle and we're going to call this thing PQR, just like it said in the problem. And let's see if we can do it. Point Z is on side PR of this triangle such that two angles are the same. Okay, so point Z must be someplace along here. And I want to put it there so that PZQ turns out to be equal to PQZ. So my common sense tells me that Z is going to live somewhere around here. Again, it doesn't have to be perfect. This picture really is just for the purpose of setting up what's going on with the problem, but it helps to be reasonably close just because it'll help you to see what's going on with the question. So listen to what it says here. PZQ, that's this angle right here. And PQZ, that's this angle right here, are supposed to be the same. So my picture seems to capture that. I'm going to call those angles X because the problem says they have to be the same, so why not call them the same thing? Okay, the other condition says that PQR, that's the entire angle right here, this guy. I'm just going to mark it so I can remember which one they're talking about. That one right there, minus PRQ, that's this guy right here. When I subtract those two things, I get 42 degrees. Now, I don't know that my picture is a great picture of that situation, but maybe this might be like 80 degrees and this might be like 40 degrees. So when I subtract them, I might get something pretty close to 42. Okay, instead of representing this entire angle here, I'm going to call just this part in here Y, because look what they're looking for in the problem. They're looking for the angle RQZ. All right, I'm going to call that something. I'm going to call it Y. And I'm just going to remember that this part that they just told me about here, PQR, is those two angles together. It's X plus Y. And I don't really know much about this one at all. I'm just going to call it Z. Okay, so I've got three different variables in this problem. Maybe I could have done it with two because the relationships are perhaps laid out more clearly than I saw at the beginning, but that's just what I see in the very beginning here in terms of representing the parts of the problem. Okay, so now I'm going to look for some things that have to be true. What they told me here says that PQR, which is represented by X plus Y, isn't that PQR? Minus PRQ, which is Z, is going to have to be 42. So that's a condition that must be true. Now, from here, it's a little bit hard to know where to go, but I do see that using this smaller triangle right here, I can say that this angle is 180 minus 2x, right? Because we have x's already, so that would be the remaining part right there. And then using that representation along with the big triangle, it certainly has to be true that x plus y, this one right here, x plus y, plus 180 minus 2x plus z is going to have to be 180 degrees. Okay, now, again, it's hard to tell whether this is a super helpful observation, but it's definitely true. Let's do a little bit of algebra on that. I do see that the 180s are going to cancel out, and I can combine the x's here, and I'm going to get something like this: y minus minus x plus z is 0, or maybe the most helpful way to write that is that x is equal to y plus z. Okay. That was a little bit of a roundabout way to get that result, because I can also look over here and see, look at this triangle. Isn't it true that the exterior angle x has to equal the sum of the two remote interiors? So y plus z is equal to x. That's what that says. Okay, that would have been an easier way to get there. All right, so we've got this condition, and we've got this condition, and perhaps we can combine those into something that's going to result in something good. So I'm thinking about doing a substitution, about taking this x right here, putting it in here, and sort of seeing what happens. Okay, so here's what we have. We've got taking this x right here, putting it in here, my mistake. Okay, so here's what we have. Combining those two, we're going to have y plus z plus y